Today we're looking at a retaining wall design tool in the browser. It's all 3D modeled, has full engineering calculations and all the formulas and code references associated with each change. And it's quick. If I change the height of the wall, you can see we've got a sliding failure there. It's too tall for that base. Our aim with this app is to make designing a retaining wall as simple as possible. However, obviously it's an engineering design tool and there's a lot of complexity in the calculations going on in the background. But for the end user, you've got your parameters on the left and they can be expanded, the different sections. You've got your update buttons on the right and the engineering report is down the bottom. You can toggle on and off some construction detail about the form of construction. You can also toggle the rebar mode, which is nearing completion but not quite finished yet. And you can also print the report when you're finished. This will give you a view that you'll see prints nicely on set pages. So let's just have a little play around and see what failure modes we can get. If I make this toe a lot shorter, what happens? You can see that there's a sliding failure. There's not enough friction under there, and the weight of the saw behind the wall is pushing it forward. How about I try to fix that sliding problem by putting a key under the wall? So we've already got a width for key, but let's make it a very deep key of 500, half a meter. And you can see that's fixed the sliding problem. In fact, everything's okay, but what happens if I take off the heel behind? So now I won't have the weight of that soil acting from restraining it from overturning, and you can see that's an overturning failure. So let's just increase this back to a reasonable toe length. Does that fix the problem? Yes. So if that's long enough, that element there, that will fix the problem of overturning. Finally, to get a settlement issue, the easiest way to do it would be either reduce the bearing capacity or increase the loads. Let's just make the bearing capacity of the saw below the wall very poor. And you can see you got a settlement error there. I just point out that to make it easy for people, so you don't have to get your code out all the time, if you just hover over these options, it will give you the code reference and the description of the options that are available. So classes relate to what failure would result in what type of damage. You've also got that same tips on the type of fill, etc. So all the information hopefully is available as you're designing. So that's the basics, but I'll just point out a few other things. You can put surcharge loads in on the top of the wall. The reinforcement is coming soon. Like I said, it's getting there. Almost finished, but we haven't rolled it out yet. And a lot of the detail for the calculations and where all the numbers are coming from is spelled out in the calcs. the formulas and the references to the code where they're applicable. Some of this is going to be fleshed out with a bit more detail, but it's starting to get there now and should be ready quite soon. So that's a basic summary. So let us know if you have any comments on this app, anything we could change or improve. It'd be great to hear from you. Thanks. Thanks for watching this structured parametrics video. Leave a like or subscribe if you found this useful, and we'll see you in the next one.